My name is Raymond Jong, Field CTO at Isovalent. Happy to talk about how you can monitor Cilium and workloads running on Cilium and how eBPF helps to get the best performance of getting metrics out of your clusters and your cloud-native applications. I need to start with an introduction what Cilium and eBPF is before I can dive into the Grafana specifics. How many of you know about eBPF? Can I see some hands? Oh, quite a lot already, cool. And Cilium, how many of you are using Cilium? And Grafana as well? All right, cool, great. I hope this will be very useful for you with interacting with Cilium and Grafana. So let's do first an introduction for the ones who don't know what eBPF is and how we use it to monitor and to get metrics. First of all, Isovalent is the company who created Cilium, and it's maintained as an open source CNCF project with us in the community. We're currently in the graduating phase. Hopefully we graduate soon as a CNCF graduated project. And we also maintain eBPF, so we steer where the technology goes to, what features it will have in the future. And we do that with companies such as Netflix, Facebook, and others. We also have an enterprise solution for enterprise customers looking for HA features and advanced compliance and security requirements. So to start with eBPF, we like to say what JavaScript is to your browser, eBPF is to the kernel. What we mean by that is that it makes the kernel extensible in a dynamic and programmable way without changing the kernel. This allows us to, since everything goes to the kernel, we can attach eBPF code to such events. In the context of today, how we use it is if you want to monitor your applications, if you want to monitor the performance of your network, we can attach eBPF programs to, for example, an event, a kernel event, when a network device sends a packet on the wire. We can get metrics out of that. We can see the throughput, the performance, and the latency as such. And eBPF is under the hood running in Cilium for all kinds of use cases. You don't have to be an eBPF expert to actually run Cilium. Cilium abstracts this technology under the hood, so based on the configuration you set, so I will show an example in a demo as well, Cilium mounts the required eBPF code on your nodes to do the things it must do. And then it provides all the networking, load balancing, security, and observability features powered by eBPF. This is a 30,000 feet view. At its core, Cilium is a networking plugin. We're also extending this across clusters and also working on a so-called transit gateway to even extend this technology across clouds without actually having to run Kubernetes, right? So it will be a gateway for workloads in the cloud. It provides all the network policies, all the metrics, IPv6, BGP for on-prem, and it supports all kinds of platforms. So you can run Cilium on OpenShift, on bare metal, on VMware-based clusters, Rancher, and obviously all the cloud providers as well. On top of that, we built an observability layer called Hubble. And Hubble allows us to provide the metrics we're going to show today, but also provides a UI and a CLI to monitor service-to-service communication in your namespaces of your applications. We're also able to export flows to SIEM platforms such as Splunk and so forth. We have also talked about Service Mesh yesterday in another talk. We can also do ingress, gateway API support for getting traffic, load balance through your services into your applications, and also do layer 7 path-based routing and such. Today we're focused on the observability part mostly, since that's where the integration actually happened with Hubble and Grafana. So let's start with some of the observability challenges. One of this challenge is that obviously connectivity is layered. Imagine an application gets reports from users that the application is slow. Then the application team wants to investigate why this is, right? And they have specific instrumentation, perhaps, why they can see what is lagging. Maybe a specific service in an application is slow. But then they think it's the network, right? Network is always to blame. So they go to the network team and they say, it's slow, I have latency, what's happening? But the network team has visibility in layer 3, layer 4, obviously layer 2. So you have this finger pointing problem. Where exactly is this problem? Why is my application slow? and how to solve this. Another problem, especially in cloud and huge scale, is the signal-to-noise problem. So imagine you run multiple clusters on-prem, maybe in cloud, you're dealing with a ton of information, right? Workloads in Kubernetes are ephemeral. You are not able to effectively track IP addresses. They come, they go. When you scale out, you see new addresses. In some circumstances, you may be seeing only node IPs. And in cloud, you have different tools, right? You have a different dashboard maybe in AWS than you have on-prem, for example, with OpenShift. So it's also the different platforms with all the signal-to-noise problem with a lot of information which doesn't give you any context of the application itself. So you can also monitor flows through traditional network devices. Most of the time, that's a bottleneck, and you only see layer 3, layer 4 related information. There's no context of the application. So that's existing mechanisms which fall short. Cloud provider network flow logs provide information about nodes, about pod IPs, but not context of the actual application. You may want to monitor your nodes specifically. You can get real deep statistics, but again, the nodes themselves don't have any context of your application. You can instrument your application. You can modify your application code to get metrics. That works for certain parts, at least at layer 7 for your application specifically. That obviously has overhead. You have to maintain that. You have to instrument that effectively, and you only see the metrics of the application. And obviously, sidecars, service meshes, also promise this observability capabilities. However, sidecars have the downside of, at least the sidecar-based service meshes, that you have another tool with operational overhead to maintain. It costs memory. You have proxies running into the network. That's obviously more complex. So I want to explain why Cilium is different and how Cilium solves this problem. Instead of looking at IPs, we are working with identities. And to explain this, think of a front-end workload with a back-end workload. Obviously, your workloads in Kubernetes have metadata attached, and each unique set of those labels are assigned a unique identity. For Cilium, it doesn't matter if you have 1 pod or 10 or hundreds. If they share the same metadata, they have the same identity. So imagine if you have 100 front ends talking to 10 backends. Those 100 front ends will share the same identity and are allowed, for example, to connect to the backend based on a network policy, which checks for this identity when it receives traffic. And that's where Cilium works, all across the metrics, the observability, but also the security. Coming back to Hubble, we have a UI. I will show that in a demo quickly as well. It's a service-to-service communication overview. So you will see on namespace level what communication is happening within the namespace, what traffic is going ingress into your namespace, and egress towards, let's say, external resources, external in your data center or in the cloud. CLI is really great for platform engineers looking for advanced troubleshooting, labeling, filtering capabilities and such to see and to follow specific traffic flows. And today we'll show it in a demo how the metrics piece allows you to extend Grafana with the information Cilium provides to get rich metrics in Grafana and using dashboards to get the metrics you need, and even when you instrument your application, also to see traces using exemplars. And this is all powered through eBPF, and Hubble interacts for this component with Cilium on your cluster. This is a detailed view of the flow visibility. For example, we're observing a specific label, so a specific identity, namely a class X-Wing, and we can see all kinds of flows. First of all, we can see the DNS lookup. We can see actual HTTPS requests to a specific FQDN, so we can see what it tries to connect to externally. And we can also obviously see drops when flows are being dropped by network policy. This is a quick view of the service map. I will show this in a demo as well, so I won't spend too much time. What I do want to highlight is that you can see, we see layer 7 information. We can actually see what kind of methods, what kind of protocols, ports, and layer 7 information such as HTTP GET, POST, return codes information in there as well. So this allows you to make informed decisions if this is normal traffic. You can, on API level, you can secure your workloads using Cilium layer 7 network policies as well. So, as I said, the Grafana LGTM is obviously referring to looks good to me, but also obviously to the Loki, Grafana, Mimir, Tempo stack Grafana provides. Isovalent is partnering with Grafana as well to provide rich dashboards, both open source and enterprise, to provide you all these metrics in a readable way. And obviously, using eBPF, that's the best way to get those metrics with the lowest overhead in there. So without instrumentation, we can actually follow and see and monitor HTTP golden signals. So we can see things such as request rates. We can see the duration of requests. We can see response codes and error codes in those requests. So without instrumentation of the application, by just monitoring layer 7 traffic, we can export these metrics, for example, into Grafana. But we can also detect transient network issues. So we will monitor nodes. We can see the performance of nodes. We can see the throughput, but also ECMP information such as requests, replies, missing SYN ACK in the TCP layer, and all the DNS-related information. So if there's something wrong with DNS, and that happens quite a lot, we can see what's happening there as well. If you additionally want to instrument your application to, for example, have tracing, that's fine. The benefit here is that Hubble is capable to detect those traces effectively and export those traces with Grafana, and Grafana will show these as exemplars, right? So you're not get overloaded with a lot of tracing information, but they highlight specific examples of traffic which were slow or delayed or having such latency, and you can click on such exemplars, query this information with Tempo to see a specific trace and where time has been spent or what went wrong. And I will show that in a bit live. This is such an example. You can see the whole trace where the crawler in this example tries to read through the loader the resumes app, and you can see why that's slow. Also, at scale monitoring, day-to operations is important. So what I want to point here to is that we have ready-to-use dashboards ready at the Grafana marketplace. So we provide agent metrics, operator metrics, Hubble metrics. You can then download them for free at Grafana. We also introduced policy verdicts as well. So this is an example of agent metrics. This will show health of nodes, performance of the nodes, the throughputs of your nodes. The Hubble metrics will, again, summarize all layer 7 DNS responses and such. And the operator metrics, if you use an operator, for example, in cloud, a Cilium operator keeps track of cluster-wide information, such as identities. It really helps to monitor that as well. So you can monitor, let's say, IP address exhaustion, or, for example, identities being allocated in your cluster, and which is important at scale. And finally, what we recently released is a network policy verdict metrics. This allows you to see on a namespace level how much of your network policies are matching actual flows. So the goal is here that you have as much as green and purple flows instead of red or yellow. What that means is if you have red flows, obviously you have drops. If you have yellow flows, it will not matching. It will be allowed all or not matching a specific rule. And if you have green and purple, it means that you have matching flows for specific layer 3 and layer 4 traffic. And in case of purple, you can have matching flows on layer 7. That means that you have a matching network policy, so you can really monitor the compliance of your network traffic in that given namespace. Let's move to the demo. I see I have plenty of time, actually, so that's pretty good. What I've done is we have a demo application. Let me quickly show that. So we have a tenant jobs demo application in the tenant jobs namespace. Let me refresh this. Is my Wi-Fi ready? It's a bit slow. While this is loading, let me, oh my God, this Wi-Fi. Let me try again. All right. Let me start with how do you get this metrics, right? So typically customers run Cilium through Helm values files. I'm running a cluster for this demo in Google Cloud. I want to highlight a few of these settings. So what's important here, under Hubble, the component for the monitoring and the metrics, we need to enable metrics. And specifically for this demo purposes, I want to I want to see flows of DNS, I want to see drops, TCP, ECMP information. But more specifically, I want to focus on HTTP traffic. So I'm adding a lot of parameters, but this gives me all the layer 7 information out of the box. This is also documented at the dashboard, which you can download yourself, so don't worry, it's all out there. And then you enable dashboards and you add, obviously, the service monitors to get that metrics out there. So this tenant jobs is running in a tenant namespace. Can everyone read it in the back, by the way? Can you read it in the back? Yeah, all good. So it consists of multiple services, and what we're going to do is monitor the performance of this application, so the communication and traffic duration between those services. And let's assume that we are an application team and we make changes to this application and we want to monitor the performance of this application. All right, let's go back to Hubble, which is not working. Okay, it's not that important. However, the dashboard should work. So I'm going to browse. Let me quickly show the agent metrics live. So again, this is a small cluster, nothing special happening here, but we can monitor the health of the nodes. We can also see BPF memory usage, all this low-level information, API calls, and such. On the operator, this hasn't a lot of information given this is on GKE and this operator doesn't expose a lot of metrics, but we can monitor that. But better is the Hubble metrics. This gives an overview of all related flows, all the layer 7 DNS related flows. So if something is, for example, dropped, you can see reasons as well. You can filter on this. And there should also be general HTTP information, such as methods and throughput. But for this example, we are going to focus on specific HTTP metrics by workload. And this dashboard is also on the Grafana marketplace. And we're now looking at the performance of this tenant job. So for the purpose of the demo, I'm going to zoom in for the last 5 minutes and refresh on 5 seconds. As you can see, everything is healthy. We have 100% incoming requests. Let's see what happens when we update this application. Given this application is managed through Helm, I made a little script to make this demo a little bit easier. And this basically, step by step, updates the application with different values. So first of all, we enabled a layer 7 network policy. This triggers the layer 7 metrics. I'm quickly highlighting, let me zoom in a little bit. Is we have an allow within namespace rule to allow communication within the namespace. We also have an ingress rule and an egress rule. So let me check. This is the egress rule. This allows communication for port 80 to external resources. And we have an ingress rule for specific services we want to expose so we can use this application. So what we're going to do first is we are going to simulate more requests. So we're going to deploy. Oh, the network is unreachable. There is. Oh, my Wi-Fi is killing me. Yeah. Okay, that's not nice. Oh, the speakers. That's why Hubble is not responding. Come on, Wi-Fi, otherwise I'll get my phone. Now it should be able to actually, let me check if this is reachable. Okay, we've seen this. Okay, we're going to update the application to generate more resumes for this job. So we're monitoring the tenant namespace, and you can see live we're getting more crawler components in this application, so this will generate more requests. And don't look at the operator. This is a little thing in this demo, but it will actually work in Grafana. So let's check what's happening here. So this takes a bit, but we can already see the request duration is increasing. So we have updated the application. There are more crawler components. They're hitting the application harder. So the duration will actually increase as well. But we should also see the request volume rise. We can see the duration by source, so we can see which component gets slower responses. And we can also zoom into the core API component. And here you can already see we get more requests per second. All right. Let's do a next step. So we're going to deploy a new configuration of our app. And we want to see, let's assume this application team makes a mistake and there's something wrong, right? So this app has been updated. So let's wait for that. As you can see, we are deploying a new core API version. All right. Let's see what happens. So we're still monitoring. We're currently 100%. All good. Obviously, this takes a bit for the metrics to appear. But what we should see is that the success rate will fall a bit, slowly but surely. There you go. We already see a few requests getting return codes 500. We see the success rate is decreasing. We're not 100% successful anymore. And we can see rich return code is actually being created. All right, so we see the result of this change, more errors, so that's definitely not good. We're also going to simulate the increase of request duration. So for some reason, maybe the network is slow or there's latency between nodes. So let's check how Grafana picks this up. So in this example, we're deploying a new core API component. This will respond slower to requests. And this will be visible in Grafana as well. So as you can see, we still have more requests per second. We have lower request success rates. We are getting more and more 500 return codes. But we're looking at duration, right? So the duration should now increase. Yes. Again, this takes a little bit of time. And then, again, this is without actual instrumentation, so out of the box using Cilium. While we're waiting for this, I'll do the next step as well. So if your application is able to export tracing headers, if you use OpenTelemetry or you're using instrumentation, Hubble can pick those up and export these metrics effectively for Grafana. So we're going to do an update of this jobs app to support these traces. So we're going to apply a new version. Let's see that happening. In the meantime, all right, so you see a new crawler, new core API, new job posting. All these services are now instrumented using OpenTelemetry, and we'll see how this appears in Grafana. Now we can finally see that the duration has been increased, what we expected in the previous step. And now we want to deeper troubleshoot the communication of this application. And we should see exemplars coming in Grafana. And exemplars are timestamps, are traces in a specific time, which collects data for the specific response and why that is slow. And they appear as this little green boxes, and if you hover over them, you can actually see already a summary of information. I want to wait a bit for an exemplar in the higher duration, because that's always a good example. Because, for example, if I click on this exemplar, I expect, if I query this with tempo, everything is responding within reasonable times. I don't see error codes, so this is good. But we're more interested in exemplars. There's one. So this is one exemplar with a high duration. So I want to inspect this specific one. Let me zoom in. So let's query this. And here we can see most likely why and where time has been spent and why this took so long. We can see the method, we can see the HTTP route, we can see response codes. In this case, it was actually a 200, but it took a long time. Okay, this is a good request. We still have this longer duration. But if there's something wrong, you can also see how much it has retried a specific request and what went wrong between which service. All right. So let's make sure we fix this demo and bring it back to a healthy state. So in summary, without instrumentation, you get already super rich information with Cilium, with metrics enabled in Grafana, using Hubble Layer 7 information, and using these dashboards, which are available on the Grafana marketplace, you can effectively monitor application performance, both as a platform engineer, but also as an application or DevOps team. You can give access to those teams, and they can monitor it themselves. So this concludes the demo. We're now going back into a normal state, and I will show the graphs in a minute. If you want to try this yourself, I would highly recommend our labs. We have 21 plus amazing labs at isovena.com/labs, including this one. So you can try and learn it yourself, how to enable it, how to get the right metrics. It's based on Instruct, so you get a real environment in a VM with a kind cluster, with Cilium, so you can really check things out, how things work. You can also watch or join the Cilium community at Cilium Slack, cilium.slack.com. All this is documented as well at cilium.io. If you want to know more specifically about eBPF, go to ebpf.io. Actually, tomorrow evening, there will be an online eBPF summit as well. So if you want to join that, you can still register and join that summit there. There are some amazing talks from people, such as companies as Facebook and Netflix, how they use eBPF and Cilium to get the performance they need. So with that, thank you for being here. I'm happy to take any questions.
Big congratulations on the complex demo. I know it's a feat.
Yeah.
So we did receive some quite interesting questions. The first one is, does the Cilium agent utilize eBPF exclusively to gather data, or does it put together the information from different sources?
Oh, that's a very good question, actually. So eBPF for layer 3, layer 4 information is being used in Cilium. So the Cilium agent will be queried by the Hubble component for that information, and that's all through eBPF. The layer 7 is actually the built-in proxy in the Cilium agent, which is an envoy proxy we use for all the layer 7 capabilities. So we get that information from the Cilium agent using the envoy metrics. But yeah, that's basically how it works.
The next one is, are you collecting any data, or is all the data remaining inside the cluster?
Cilium is not maintaining that data, right? So it has a limited lifespan in that sense. If you use Hubble CLI, you're looking at live flows. You can filter on it and you can see the live, but you're not storing that yet, right? You can export those flows. And in our enterprise offering, you can also have a component which does that automatically for you. Hubble gives you a present view, gives you the ability to see what's happening right now. But using Grafana, you can obviously store that maybe for a longer time, depending on your Grafana environment.
The next one, are you happy to keep taking questions? Because they're coming in fast.
Good.
As GKE uses Cilium, can one use Hubble directly, or is it necessary to replace GKE's Cilium with a custom one?
That's a bit of a interesting, complex question, or it's not complex. It's true. Data plane v2 Antos is using Cilium out of the box, or if under the hood, I would say, but they're not exposing all related Cilium features, and that's obviously for supportability reason and on Google's side. So no, you cannot use Hubble on top of Google clusters to get these metrics. The demo I'm showing obviously is not data plane v2. It's basically replacing using the old data plane v1 component to run Cilium. And then you can manage Cilium yourself and you get the metrics you need for running on Google.
Cool. Do we need to be the cluster operator in order to use eBPF?
So I need to be the cluster operator in order. Well, yeah, if you're a platform engineer or the operator or maintainer of the cluster, yes, I would say, because you need to manage and configure Cilium cluster-wide. So if you're not the cluster operator and you're not sure if your platform is using Cilium, make sure to talk to the cluster operators, your platform engineers, or the team managing your clusters to ask if they want to try out Cilium, and you as an application user DevOps team can actually benefit from these metrics.
Should my application be modified in any way for exemplars to show the trace information? If yes, is there a guide for this?
Okay. So if you want to have these exemplars, yes, you need to instrument your application. So I think the best source would be OpenTelemetry documentation, how to do that. Cilium is just, effectively getting these flows, and using Hubble, we get these flows into Grafana the most effective way. We understand that we see trace data, so Hubble makes sense of that and reports that to Grafana, but you have to instrument your application yourself, yeah.
I really like this question. Is eBPF not breaking a front door into our security? Why is it safe?
Well, first of all, eBPF is governed by the eBPF Foundation, so they govern the rules about what we're going to do and not being able to do with eBPF. eBPF has also constraints, limits. Think about, for example, memory size eBPF can have to run in the kernel. That's also a reason why, for example, layer 7 load balancing is not yet done through eBPF, but instead using our Envoy embedded proxy. Because it doesn't fit the constraints of eBPF. And those are for good reason. You don't want to have tons of memory running in kernel space as you run your operating system. So that's one of the things we can do. But you can also use eBPF to monitor eBPF, right? We have a runtime security component, and you can actually monitor and safeguard eBPF execution or privilege escapes or namespace escapes as well. So you can really monitor itself if you want to.
Can Cilium and Hubble also be used with Nomad instead of Kubernetes?
Yes, it can be done. I was pointed to a customer with Nomad, and that definitely works. It's quite new, but yes, it can be done.
Cool. And the last question, does OpenTelemetry overlap with Prometheus or Tempo when using Cilium and Grafana stack, or should we be using both?
There is maybe some overlap, because what I try to show here is if you use the layer 7 metrics, you already get this duration, you get the response code, you get all this information about latency and such. OpenTelemetry part obviously does the same, right? So, but it gives this more specific trace IDs and exemplars to see in a specific request what happens. So if that's additional information you need, then definitely use OpenTelemetry. But what I'm trying to say here is that obviously you already get a ton of information by actually not instrumenting your applications. And that obviously has benefits of reducing overhead, management, operational complexity and such.
How much extra resources do the metrics need?
That's a multidimensional answer, because this will depend on which metrics you enable, how much traffic you are pushing, how much filters you are applying. Obviously, the more you want to see, it will cost some overhead, right?
Yeah.
Nothing is free, unfortunately. Using eBPF, we do it the most effective way, but getting more metrics, getting more flows will have some overheads, right? So it really depends on the amount of workloads and amount of traffic.
And the final question, can one use Cilium in an AWS EKS cluster? Is there documentation for that?
Yes and yes. Yes, absolutely. You can run Cilium in multiple clouds, including AWS EKS. You can run it in different ways as well. There are multiple configuration guides on the Cilium.io website, which highlight how you should configure Cilium on AWS. You can either replace the AWS VPC CNI with Cilium, then you have all features with Cilium. Cilium also takes care of IP address allocation and such. But we also see customers running chaining, which means that AWS VPC CNI works together with Cilium. AWS VPC CNI takes care of allocation of ENIs, IP addresses, and such. And Cilium does the load balancing, the metrics, the filtering, and such.
Right, thank you so much. Let's have another round of applause for Raymond.
Thank you.